Okay, sorry, it should be connected now. Little dot is pulsing. We are talking about Genesis and a literal versus a non-literal interpretation of the Bible. Yes?
You need to call that young lady who's traveling back to Miami.
Oh, okay. Elisa, what did she say? Thank you.
No, she signed off because we're waiting.
Ah, okay.
So you need to call her back so that she can get back.
Oh, okay. So let's try that. And I wonder, was she...
Is she a new student?
Call Elisa Faulkner?
Yes.
Yeah, she's part of the group.
Yeah.
She was here for the first session, but now she traveled away. So she should be here for the next session next week.
Do you have a schedule copy, by the way?
Yeah, I thought I had in the syllabus. Did I not give you a syllabus?
I have a digital copy.
It's there. Page 6 is the most important one. Hello? Oh, hi. Okay. Excellent. Do you want to try Facebook again? Okay, thanks. Now this time. Oh, extra? Okay.
Yeah, extra.
Everyone else has the handout for today? Yes. There. Okay. Yes? Hello? Okay, there you are. All right, let's try this. I don't know what... were you able to raise chapter 1 of Genesis?
Yes.
Yes? Okay, so that's what we're talking. We just started now. All right. Contrasting the literal versus the non-literal interpretation of the Bible. And we're mentioning, picking up on the word day, because it's 6 days, right? And then on the 7th day, God rested. So the key issue here is day, and how can the whole world, the whole universe have been created in 6 days from the biblical perspective or the religious perspective, if in fact the physical evidence is millions and billions of years, which is much more than any one day, right? So I'm saying there's a big difference if we interpret the Bible literally or non-literally, okay? Because on the first day, the very famous words, let there be light, and there was light. But then he separates the water of the sky from the water of the earth or the ground. Then here we go. Then God said, let there be lights in the vaults of the sky to separate the day from the night. Let them serve as signs to mark sacred times, and days and years. And let them be lights in the vaults of the sky to give light on the earth. And so it was, God made the 2 great lights, the greater light to govern the day, the sun, the lesser light to govern the night, the moon, and he also made the stars. So it's all about celestial bodies, luminous bodies. At that time, it was probably not known that the moon is not a luminous body. It's an opaque body, doesn't give out its own light, but it's reflecting the light of the sun, right? Okay, and it does that when we're at night. So that's the moon, etc., etc. And so separate light from darkness, and God saw how good it was. So there was evening and morning, the 4th day. So how can we have a first day and a second day and a third day if the sun had not been created yet? So there are, if we, right, see? If we take the text literally, we find internal contradictions. Therefore, unless we throw out the whole Bible, we cannot take the Bible literally, right? Rather, this is a theological passage. This is a theological passage that is trying to give us a world view of the time. That basically time was sacred, and that that there was one particular day that belonged to God. And that was the seventh day, which in Hebrew is what? The Sabbath. Exactly, the Sabbath, the Shabbat, which is the holy day. And if God rested, who are you not to rest? So this first book of Genesis, first chapter of Genesis, is attributed to a group called the priestly tradition, right? The priest, which priest? Catholic priest? No, this is this maybe 1,000 to 1,500 years before Christ. Okay, these were the Jewish priests of the temple in Jerusalem, trying to highlight the Shabbat, the day of rest. Okay, and God worked. God did all his other work on 6 days, Sunday through Friday. So we are to imitate God because we are his image. And so we work Sunday through Friday. In the Jewish system, on the Shabbat, we rest. So that's the meaning of this. And therefore, those days are not days of 24 hours. They're periods of time. So once we get off the day of 24 hour, we're in a better shape to keep the biblical tradition. But we do see that this does not really contradict the datum from science. In other words, what we see naturally, which is what? A progression, right? The branching, the anagenesis and the cladogenesis speaks of a gradual complexification that plants and animals and living creatures, we have become more complex. We're not unicellular. We're not prokaryotes, okay? We are very sophisticated, organically speaking, and very complex. So there has been a gradual complexification. And when we look at the development in Genesis 1, we see that gradual complexification. Starting first with the biggest separation at plain sight. What is the biggest separation at plain sight? Light from darkness. Light from darkness, okay? And that's how it starts. And of course, keep in mind, these are all religious people. It's a religious perspective. The Bible is a book written by religious people for religious people, right? So it's all that same universe. And so as religious people, do we want to live in light or darkness? Right? We want to live in light because it's a religious light that is involved here. It's a spiritual light and so forth. And so in the beginning, God said, let there be light, precisely to dissipate the darkness, because darkness is equated with chaos, sin, evil, ignorance, etc. So we want to be in the light, and that's the first thing that God does, right? So from that perspective, it makes sense. Now, you flip to the science, and what are the scientists telling us? What are the astronomers telling us? All right, that happened about 13.5 billion years ago. The Big Bang, the moment of singularity, okay, where everything came out from nothing, because what was before the Big Bang? There was nothing. So that sounds like an act of creation. If there was nothing before the Big Bang, and then there was everything after the Big Bang, at least in energy, in intense energy, and the first microseconds were already generating elements, the formation of elements. First, the subatomic particles, and then those particles coming together into elements and so forth, all right? And then this whole explosion and expansion. First, there's an explosion, then there's an expansion of the universe, which continues to expand to this day. But the scientists have actually been able to put a time on it. And it wasn't a day or 6 days, it's 13.5 billion years ago. And our system appeared about 4.5 billion years ago, the Earth. So there's a chronology, is what I'm trying to say. There's a chronology in Genesis 1 that is gradual and goes from the simplest, which is light, to complexification of life. And there's a chronology that is a fact of nature that science is telling us has happened also for 13.5 billion years. So where's the contradiction? They're actually complementing, right? This is an overview. We'll get into more detail later. But you see, as long as we don't interpret the Bible literally, as long as we're not fundamentalists, we can actually match up Genesis 1 and 2 and 3 and 4 with the story of creation, specifically with anthropology, with the generation of the human race, the human species. Okay, questions, comments? See? John, please.
I was just thinking, so is it safe to say then, based on theory, Big Bang Theory, that if the universe is still expanding, that new solar systems and new worlds are still being created as you go out?
Well, there's also the whole conservation of energy and matter and energy and the transformation between matter and energy. That was Einstein's one big contribution, that E equal mc squared, right? Where you have E is for energy, M is for matter. So there's an equivalency there. But we believe that the sum of matter and energy is already contained within the universe as such. So it's one creation, all right? That we can tell, at least from the natural perspective. Theologically, it could be different, hypothetically, but at least factually from what can be measured. And that was another big contribution of Hubble, was when we finally got a telescope out there in outer space, so it didn't have to deal with all the atmospheric interference, that the universe is not only expanding, but it's actually accelerating, which is counterintuitive. Because you would think that something is expanding from the center, it will start decelerating, right? But it's not. It's expanding in an accelerated term. So it's counterintuitive. Just means that there's a lot of mystery. Number one. Number two, we can talk about light and energy, matter and energy that is light, matter and energy, but there's also dark matter and dark energy. Right. Dark simply because we don't have yet the instruments to access it, all right? The easiest example is the black hole. Why is a black hole black? What does that mean?
Not even light can escape.
Exactly. Not even light can escape. In other words, there's such density inside a black hole, at the nucleus of a black hole. There's such density that not even a photon, remember, a photon has a dual property, acts as light, that also acts as a particle. If it acts as a particle, it's subject to gravity. Mm-hmm. And so not even light, 300,000 kilometers per second square, is able to escape a dark hole. And that's why we can't see it, okay?
How do you know there's light in it?
Hmm?
If you can't see it, how do you know there's light in it?
Exactly. It's by inference, indirectly, because what scientists are seeing is that things are getting sucked into the black hole. Galaxies, entire galaxies are getting sucked into the black hole and disappearing. So once they were there, they're no longer there. So it's a black, whereas in the density in the background, there should have been a galaxy there, it's no longer there. So there's a lot of inference, but it's a very solid mathematical inference, okay? Things are disappearing in the universe and they're getting sucked up by these black holes. So that's dark matter, but even more, I mean, the percentage is, I think it's in the 70 or 80% of the universe is dark energy. So we're only living in a very small percentage of what we see around us. Mm-hmm. Between what we see is essentially light or visible matter and energy. But there's another dark, as in occult, not in the evil sense, but just simply not accessible to, certainly not accessible to our senses and not accessible to our instruments yet. Mm-hmm. Okay, so all this to say that as long as we don't interpret the Bible literally, we can find a match. We can actually find a complement. Because what science cannot tell us, then theology or belief can take us there, can give meaning. Remember, for the scientist, unless I can measure this, this doesn't exist. Okay? But if I can measure it, then it exists. Now, love, I hope that we all agree that love exists. So does hate. But how much does it weigh? How do you measure it? Can't measure it. So it's outside of the scope of the empirical sciences, strictly speaking. They've actually come up with other measures to try to measure sentiments or feelings or passions. But the essence is unmeasurable. Now, I just want to go on for a few more minutes because I'm extending already. But this is my personal theory that we live in three worlds simultaneously, and it's just a kind of the setup for the lecture on origins, which I'll continue next week. But what I'm calling three worlds, and actually I should put this in quotations, because it's a world in metaphorical sense, not in the physical sense of planet Earth, all right? These three worlds. But generally, we're only aware of one world, which is the world of our size, what we can experience with our senses, mostly through sight, but also sound, and then touch and taste and hearing. But there is a microscopic world. I have to realize now, thanks to science, that there are millions of bacteria covering my hand, which I cannot see at plain sight. But if I get a microscope, I can see them. All right, so that's the microscopic world. The microscopic world can begin at the cellular level, and then it goes down deeper into that at the molecular level, and then beyond the molecular level at the atomic level, at the subatomic level. What are the three basic subatomic particles? In other words, the three particles that make up the atom.
Protons, electrons, and neutrons.
From the chemistry teacher, yes. Okay, so the three subatomic particles of the classical model, protons, electrons, and neutrons. But they have also, it turns out that they are also composite. They are not the simplest molecules, okay, or matter or energy. They're made up of subatomic quarks. Exactly, the quarks, all right? And then it's still debatable whether the quarks are composite or not. But at least scientists have gone down to the quark level. So you can think of how many layers of the microscopic, like quantum layers. The cellular could be one. You want to go down to the atomic, from there to the molecular, let's say, macromolecules like proteins and so forth. That's the second level. From the molecular down to the atomic, 3, subatomic 4, right? And then the quarks 5. There are at least 5 layers of depth of size at the macroscopic level, which is happening right now, independent of whether we believe it or not, whether we agree on it. It keeps us alive. Okay? There's something else. Oh, okay. And well, let's go up then to, I'm also putting normal macroscopic because we can see at plain sight, and we can even see stars, right? And at night, especially now that the lights went out in the city for a few days, we can see even more stars, all right? I didn't bother, I didn't think of checking for the Milky Way. We could see the Milky Way, but in very dark areas at night, one could see the Milky Way as a cluster of what we call stars. So when we look up at night, think it's in the middle of the night, and we look up at the night sky, we see those little dots, we call them stars. And we call them stars simply because they're very, very far away. But many of those dots are what? Some are actual planets, the bigger ones and the ones that twinkle, but others are actually galaxies, whole galaxies, which include millions of stars. Sun is a star, okay? But they're galaxies, And the only reason why we see them as a single dot is because they're astronomically away from us. It's like the old example of two persons with a flashlight each at night. There are three persons actually. One doesn't have a flashlight and is looking at two others who have a flashlight or pointing this way, right? And when they're close at night, nearby, you can see the two lights of the two flashlights. But as either they walk away or I walk away or we all walk away from each other, those two dots, the dots of light, start getting smaller and closer, right? Smaller and closer. If they walk far enough away, if we walk far enough away from each other, those two dots will be seen as one. Eventually they'll merge. It's a perspective thing. But there's still two flashlights. They're just very far away, okay? The same with the stars at night. So that's why I say normal microscopic, we can see a plain sight, but there's a lot that we don't see. In fact, most of it we don't see, and most of it we don't hear either, thank God. For example, if I had a radio here right now, okay, AM, FM, whatever you want, we tune it in, we plug it in, we tune to a particular state. We can hear each frequency, we can hear different music. What do you like? Country music, what do you like? Hip hop? China's into hip hop now. Whatever you like, we can hear talk radio, right? That's because we have the radio. Thank God that, but those waves are going through this building right now, all of them at the same time, of all the stations, AM and FM, right? Imagine if our ears could hear all those waves. We'd go crazy because we'd be hearing the chaotic amount of noise, right? And that's just the radio. What else is going through here? Well, if I get on my app, you know, I can look at my bank account on my app, on my cell phone, which means that that signal is also coming through somewhere, through a satellite or something, right? So that's another wave that is also going through this room. So there's all kinds of information. There's top secret information that's going through this room right now. If I had the proper equipment, I could pick up on those waves too. So imagine all the energy that is going through this room right now. Thank God that our senses are limited, especially the hearing sense. Because otherwise, we hear very little, really, of what is the range of waves that are going just through this room right now. Thank God for that, right?
Maybe that explains my tinnitus in my left ear.
Yes, exactly.
Never goes away.
Exactly.
Maybe I'm tuning in.
The wiggling of the earlobe.
I tell my students, be grateful because 23 years old, they go ringing in my ear and go to the health center and they tell me it might not ever go away. They're right.
Yes, exactly.
It's low. I don't even notice it anymore.
Is it really? And it's just 1 year? Oh, wow. Okay.
But anyway.
It's there.
Yeah, but I don't even think about it. It's amazing how you adapt so easily.
Yeah, I've heard that some people with metal work on their teeth have picked up some kind of wave. Sometimes they pick up some frequency, and it's like a vibration on the jaw, which is very uncomfortable.
I think it's tied into TMJ.
Is it?
I think so.
Okay. All right, so that's what I'm calling the super macroscopic, right? That is really beyond us, but it's there. And we live in these three worlds simultaneously. But we're only aware normally, especially without instrumentation, on the normal, what I'm calling the normal microscopic world, which is our senses, our five senses, the range of our five senses. Okay? The distances that occur, it's interesting that proportionately, the distances that occur between the supermicroscopic objects and the microscopic and supermicroscopic objects is similar, the proportion. In other words, the distance between galaxies, for example, is similar in proportion to the distance between atoms in a molecule, within a particular molecule, okay? Atoms that may be adjacent to each other, but in proportion to size, the distances, there's a lot of empty space, right? Empty space if we don't consider waves, but if we consider wave, there's no empty space because there's a wave going through everything, some kind of wave, right? But at the level of matter, the distance between the galaxies in the universe is proportional or kind of similar to the distance between the subatomic and submolecular particles. So there's a lot of empty space, if you will, also in matter, in the matter that surrounds us. Okay, there's more empty space in this computer than there is actual matter for the volume that it's holding. And there are some spectacular photographs, time photographs of galaxies going through each other and coming out intact at the other end. Because the distance between each solar system within that galaxy is so huge that another system could go through it, all right? But to us, it just looks like two galaxies went through each other, all right? So if we're there, the distances are huge. Now, sometimes gravitational pull could have an influence. And we'll talk more about that in the course in environmental bioethics. But just to give you a proportion, what I wanted to do with that is just set the stage for talking about origins, which I'll stop now. But we'll get into origins then. I mentioned already the origin of the universe, just with the Big Bang as a reference, and then the origin of Earth 4.5 billion years ago. A billion in the US, an American billion is 10 to the 9. That number is huge. We don't even agree on the billion because a billion for Europe, a European billion, is 10 to the 12. Okay. What we call a billion in Europe, they call 1,000 million, which is really what it is. Anyway, just to point out that that number is so huge that we don't even have an agreement scientifically on what is the amount. So scientific notation helps a lot, because 10 to the 9th is the same here than in Europe. Okay, then this is where we're going to pick up actually next Saturday is the origin of life. Almost 4 billion years ago, the Earth needed to cool down a little bit to be able to have sustained life. In other words, we needed liquid water. Okay, I'm going to stop there. And I thank you for your patience because I went over a little bit. Questions, comments? Yes?
We're actually not meeting the next 2 weeks.
Was it, tell me, are we?
I checked today.
Not till the first Saturday in October.
Correct.
Right, yes, okay. It turns out, okay, so this is a question for you. It turns out that there was a conference that I was going to go to next Saturday, but now it's been canceled. Would you like to meet next week, or had you made plans already? Can people meet next week? Yes? Because
I'm sorry, Father Doctor, I need this.
Yeah.
right. Well, I figure we can. You see, I'm delayed one lecture actually, so if we meet, it's providential. If we meet next week, we'll be up to par because of
Yes.
the hurricane.
Absolutely.
So people are good, and all right. Okay. So we'll meet again next week, 9:15 to 12:45. I promise to be on schedule for next time. Okay. Thanks again.
Father.
Many blessings. So we'll close with this one. So hold off on the. Just catch up on the no new summary yet because I really haven't finished.
Okay.
Just catch up on the late summaries. This week, okay?
Thanks. Bye, guys.
You're welcome. Thank you very much. I'm gonna stop